All right, so the idea is that if we have two triangles that both have a right angle and both share an acute angle, then the two triangles are similar by the angle-angle postulate. We learned that in geometry. And that means the side lengths are proportional, which allows us to ultimately say that as long as I have a right angle with maybe a 30-degree angle in it, or a right triangle with a 30-degree angle in it, but every time I look at sine of that 30-degree angle, I'm going to have the opposite divided by hypotenuse always reduce, because of the proportionality factor, always reduce to a 1 over 2. Does that make sense? So now the easiest thing for us to do then is to say, well, what would be the best triangle to really work in to develop all these ratios and understand and learn these ratios the easiest? And that's the triangle that has a rate or a hypotenuse of 1, okay, with a unit circle. Because every other triangle then can be shrunk down to be that triangle, right? Does that kind of make sense? Through a scale factor. So what we're doing here, I want to show you, when I was in high school, it was presented to me like this. They gave you that picture right there and said memorize it. And I had trouble doing that because I didn't understand where the values came from, okay, and why they are what they are. So I might spend more time on this than your traditional trig class, but I have empathy and I've been in your seats. For those of you that I understand things better if I understand where they come from. I can use it better and more appropriately if I understand why those values are what they are. So I'm going to spend time talking about that. So let's kind of talk about what they're referring to here in regards to terminal points. Okay, it says terminal points on the unit circle. So it's a terminal point, and we're going to call it. We're going to refer to something as lowercase t here. It says lowercase t is the direction, and it's clockwise or counterclockwise. So clockwise is going to be a negative number, and counterclockwise will be a positive value. Okay, and it's essentially telling you how far we're traveling around the unit circle. Okay, so it's actually going to be an arc length. Does that make sense? Okay, it's going to be some portion of your circumference. Okay, and it's going to define. Okay, it's going to define some point P. So with whatever T is, and you look at those pictures up there, T is that red arc, right? Okay, and that value. Some textbooks sometimes call it S, and I'll explain to you why they call it S here in a little bit. But that T is going to terminate at some point. That arc is going to terminate, and you're going to have an endpoint, correct? We want to know what that endpoint is. Okay, and in all those pictures they're calling it P, and you're seeing that it's 0, 1 or negative 1, 0 or whatever. But that thing could end anywhere on the unit circle, and we want to know what is the point that goes with it. Okay, so where's all this stuff coming from? I want to take a segment in here in the coordinate plane, and I'm going to make it a length of 1. Okay, and if that's the length of 1, we can start rotating this thing, right? Okay, and it's going to keep A stuck at A, but that length you see over here, it is constantly 1, doesn't change. Okay, we also know that there should be, because we've done some of this before, I could take a line that goes through B perpendicular to that axis, right? I can take a line that goes through A and is perpendicular to that new line, and we create what little thing right there? It's a right triangle, correct? Okay. So I'm going to look at that triangle real quick. All right, so we're looking at that triangle. And if I were to, so I got a lot of different triangles, right, that I can make as I move that B around. If I were to ask this thing to trace B, so as I change the triangle, just highlight where B goes. And I keep doing it. And I draw the infinite number or record the infinite number of places B could be with a radius of 1. Remember, this distance right here is always 1, right? Okay? And I keep moving that around. What do I eventually create with all those infinite triangles? A circle. Okay? Now, what is the circumference of that circle? What is the circumference of any circle? 2 pi r, right? So, what is r in this case? It's a radius of 1. So my circumference is 2 pi, right? It's the easiest version of a circumference that we could ever get, okay? Because if the r is some other number, then this just gets more complicated and more valued if it was 4 pi or 12 pi or ordered pairs get a lot uglier than what they're going to be. So things are nice when that radius right there is 1. So that's all the way around. So if I trace the whole thing and I want the circumference, I got 2 pi. What if I only wanted to trace out half of it? So maybe I only go from there to there. What would be that arc? That'd be pi, right? Okay. So I'm gonna call this t is equal to pi. I'm gonna say this is t is equal to, I'm going to say t is equal to 0, so I haven't moved anywhere. Does that kind of make sense? So that would be kind of that picture there. T is equal to 0. I haven't moved anywhere. What if I go there? What would t be right there? T would be pi over 2. What if we come all the way down here? T would be 3 pi over 2, right? And we've got a lot of other t values that we can use, a lot of other arc lengths we can use. So let's talk about why we know that those arc lengths are pi over 2 and pi. You know, one way is to say, okay, well, I know the whole circumference is 2 pi, right? So then if I only go half the way, I take 2 pi times a half and 8 pi. Or if I only go a quarter of the way around the circle, a quarter times 2 pi is pi over 2. Or if I go 3/4 of the way around, okay, I get 3 pi over 2, right? Does that kind of make sense? So that's kind of where we're getting those values. But there's maybe an alternative way of thinking about this. You guys know that there's an angle that we've been dealing with inside here. That green angle, right? I don't really want to show the value of it, so let's just say. All right. So we know that green angle exists, right? Okay. And there's going to be that circle. Okay. And actually, we know it's the unit circle, so let me just put that in there so I don't have to have that blue stuff anymore. Okay. So the question then is, if I'm looking at this unit circle and I've got that arc right there, do you guys remember anything about geometry if I would have told you that this arc, let's just say, or this angle inside here was 45 degrees? Okay? Do you remember how we can reference the measurement of that arc right there? What would we call that? Be 45 degrees. You remember doing that? Okay. We said, now when I say the measurement of the arc, that is different than saying the length of the arc, right? The length of the arc is a distance. The measurement is just a characteristic quality that we attach to. Okay. Kind of a way to describe it. But we said the central angle is in, and that's what that green angle is, right? That's the central angle of your circle. That central angle is any angle which the vertex of the angle is the center of the circle. And then your sides of your angle intersect your circle, right? Okay, so one side of my angle is the positive x-axis, the other side is the radius 1. But that's going to intersect the circle. It's going to subtend an arc. And we said that arc's measurement is identical to the central angle's measurement. Okay? So in this case, 45 degrees. Then what we did in geometry is we took, we want to know the length of that thing. So we took 45 divided by 360. We found the portion that arc was of our circumference, right? Which was our 2 pi r, correct? Okay. Well, when I do that, r for this case, r is what? R is 1. So I'm just going to have that. And 45 divided by 360, what's 45 divided by 360 as a fraction? 1/8. What's 1/8 times 2 pi? Pi over 4. Okay? So we just found out that this t value, this arc length, is pi over 4 whatevers. Okay? Because my unit of radians is maybe inches or feet or miles or whatever. Does that make sense? So it's just pi over 4 units in regards to a distance. Okay? Well, how does that relate to 45 degrees? 45 degrees in radians is what? Pi over 4. Isn't that a nice relationship? If I'm able to look at the central angle in regards to radians, on the unit circle, the arc is exactly the same thing. Okay? Why? Because of this. Remember the formula? S, or arc length. Okay? And this is just a, we did this. We did the like maybe central angle divided by 360 times 2 pi r, right? Okay. But in radians, we had this thing here, okay, is simply theta in radians, okay, and then r. I guess it's those two things there are your theta, okay, because of how we convert degrees to radians, okay. We have that formula, but remember we had the requirement that theta is in radians. Okay, but now, so S, the arc length, is equal to theta r, but r for us right now is what? R is your radius of your circle, right? That's 1. So theta times 1 is just theta, right? Okay. Some textbooks call this T S because of this fact here. We're calling it T. Okay. But there is the argument then that hopefully that linkage that helps you understand why we are referring to maybe a central angle at one stage or one situation of this course or one section of this course, and then another section we start talking about the arc that is associated with it, or the length of the arc. Okay, the angle, the central angle, and the arc are the same. Okay, does that make sense? Now, what's nice about that is if I can learn that for the unit circle, we can use that information to kind of learn everything about, or anything about other circles and other triangles, essentially, that are attached to those circles. Okay. Is everybody all right with that? All right. Now let's talk about, because we're going to be interested in. So that's where the T is, and that's the relationship, and why we say that T is the same as this angle down here, okay, this central angle. But let's find these terminal points, because right now that's really what we're interested in, is being able to find the ordered pair that goes with B right now, okay, based off of a particular distance that they give us, okay. So right now we're really not even going to focus on the angle. They're just going to tell us how big that arc is, okay? So let's say that they tell me that arc, and I'm actually going to go over here, okay? just do a couple of these pretty easy initial ones, okay? They tell you that the arc is pi over 2 units long, right? Okay. And at the same time, then that means that the central angle here is pi over 2 radians. Okay. But where does that arc stop? It stops right there. And we know this is the unit circle. So that point right there on the y-axis is identified by the point 0, 1, right? Okay. So the ordered pair that they'd be looking for when they ask these questions is 0, 1. Okay. If I come over here and they say that t is pi, now I'm going halfway around my circumference. I should stop there at that point right there on the x-axis, and it's the unit circle again. So because it's the unit circle, then the angle is essentially pi radians or 180 degrees, but your terminal ray would stop right there, right? Does that make sense? Okay. So then what's that point right there? Negative 1, 0. This all right with everybody? It's pretty easy, not self-explanatory, but able to visualize what's going on. 3 pi over 2 is going to be 0, negative 1. And then 2 pi, obviously, the terminal point is 1, 0. Okay. Is this something we can do with those? Those a lot of times are referred to as quadrantal points. And when we're referring to the angles, they're referred to as quadrantal angles because they show up on your axes, right? Okay. The lines that define your quadrants. But they're not that easy. Okay. They're not always that easy. Okay. So what if we? I guess we can answer that question down here in a little bit. Let's do a couple more. Let's do. Example 3 here says, find the terminal point on the unit circle determined by each real number t. So when they're saying the real number t, they're talking about, again, the arc length that we have to travel. Let's just get a circle in here. We're going now from 0. It's a positive number, so t is being traced out this way. That would be pi, right? That arc length would be 2 pi. Now it's asking me to go a little bit further, so I'll get a different color. And I should get to 3 pi, right? So that's where that terminal point would stop. So you got this point moving around this circle, and moved around the circle 1.5 full times, right? So what would be the point on the unit circle that's attached to that? Negative 1, 0. Okay. Eventually, we'll come back and talk about why do I need to know that number? Okay. Actually, do this now. Take your calculator. Put your calculator in. Let's do radians because of how this question is presented. Type in, let's go, cosine of 3 pi. We'll just spit back to you. Negative 1. Type in sine of 3 pi. 0. Okay? Look at 3 pi, the point at 3 pi, right? The negative 1, I said cosine, right? What's your x value? Right, 0, it's your y value, right? Okay, for sine. Type in, so pi over 2. What is the terminal point for pi over 2? 0, 1. Type in cosine of pi over 2. 0. Type in sine of pi over 2. 1. Okay? So what happens here, guys, and we'll spend a lot more time if you're not 100% confident in what we're talking about there. But what this unit circle allows us to do is to kind of circumvent the use of our calculator, because I don't now need I don't need technology to give me these points quickly, right? if I know pi over 2 and cosine is the x value for pi over 2, and that point, that terminal point is 0, 1, then I know cosine pi over 2 is 0 right away. Does that make sense? Okay. If I go 4 pi, well, 4 pi, same thing as 2 pi, same thing as 0, which is a point 1 comma 0, right? If I ask you what the cosine of 4 pi is, I'll knock my podium over. If you know what the cosine of 4 pi is, if you type it in, your calculator is going to give you that number right there. Does that make sense? Now let's talk about real briefly why it's doing that. I'm looking at my unit circle, right? Okay. And we were talking about how this angle right here is equivalent to the arc that's traced out here, right? Okay. Now, just because of what GeoGebra is able to show me right now, I want you guys to change your mode into degrees. Okay. Now, if I just ask you to look at this triangle, don't even worry about the circle right now. If I ask you to deal with the triangle, and I ask you what is the cosine of 55.31 degrees, the cosine of this angle right here for this triangle, you'd say it's the adjacent side divided by the hypotenuse, right? When I take something divided by 1, it's just that something, right? Okay. So when I look at this point B here, which is 0.57, comma 0.82, its ordered pair, because the radius is 1, its ordered pair is showing me what the cosine and the sine are for that angle. So if you type in sine of 55.31, what do you get back? 0.82. If I type in cosine of 0.57, or sorry, cosine of 55.31, what do you get back? 0.57. Okay. And then we could also go in the inverse direction. We could say, type in sine inverse of 0.82, and you're going to get back that 55.31 degree angle, right? Okay, or something close to it because of rounding error. But that is the link, really, between what we're seeing with special right triangles, okay, what we've done with the triangle approach in 5.1, 5.2 to what we're doing now. Because eventually, what is that? What do we really like is if that angle is 30 degrees. So we can get that. There we go. Okay. And we know that the sine of 30 degrees is 0.5, right? So we're seeing that 0.5 show up as just that vertical distance because it's that vertical distance divided by the hypotenuse. But what we're getting at right now with this terminal point is that this distance traveled right there. If I've got a point moving and I record its movement and it stops at B, that distance right there is the exact same thing as that angle. That angle is pi over 6. So that T is pi over 6. Does that kind of make sense? Okay. And now for this figure here, where do those numbers come from? Where does 0.87, 0.5 come from? Well, isn't this my 2 inside for a special right triangle? Isn't this my inside for a special right triangle? My n radical 3 side? So if I have 1, which is my hypotenuse, equal to 2n, does that make n equal a half? So that's where this y value comes in at 1/2. And if I type in radical 3 over 2, I should get back 0.87. Does that make sense? Okay. So those terminal points are defined by those values that came from the unit circle. Okay, it came from that special right triangle. Now here's the thing. Is the circle symmetric about the y-axis? circle symmetric about the y-axis. So if I fold on the y-axis, all right, when I say the word fold, it's really not a math word, okay? I'm looking at the idea of a reflection, right? I'm going to take this point, point B, and I'm going to reflect it over there. Okay, so when I do that, reflect B across there, it gives me that point right there, correct? Okay. Now, the arc that we'd be talking about that provides that terminal point would be that arc there. So that'd be T equaling, okay, now think about this. If that's pi over 6, right? I could have a triangle in here, and that triangle could get reflected as well, right? So what would that be? Pi over 6. So what would the length of that arc be? If this is pi, or 6 pi over 6. It'd be 5 pi over 6, wouldn't it? Okay, just take that 6 pi over 6 and subtract this pi over 6 that's right here. And that would give me the length of that arc, okay? So, we know we got symmetry, right? And with symmetry, and with reflections, distance is preserved. And what I mean by that, preserved means saved, right? Would you guys agree that that distance right there, when this point gets reflected, should be that distance right there? And you see, that's why you see this 0.87 here and this 0.87 there. They're the same, right? Got to be the same distances. However, we know in the coordinate plane that if I move from 0, 0 to the left, it's got to be a negative value. And that's where we're getting the negative. Okay? This distance here gets preserved when we reflect. It stays. And it should be that distance, correct? And that's why we're seeing that 0.5 being the same as that 0.5. Will this point eventually be able to be reflected down there? Okay. So right now we're seeing, so let me clean some things up here. We're seeing that T being pi over 6 gives the order pair radical 3 over 2, 1/2. T being 5 pi over 6 provides the exact same ordered pair, except for the x is negative, right? When I reflect down here, okay, so this would have been 6 pi over 6, right? And we know that distance there was pi over 6, right? So what's the total distance from here all the way around to there going to be? 7 pi over 6. So if T is 7 pi over 6, what's the ordered pair that's going to go with that? Negative radical 3 or 2, negative 1/2, right? It's the exact same ordered pair as that, except for now the y is negative. I come over here, I flip this thing again on the y-axis to reflect across the y-axis. So I come over here. Now, that arc would be negative pi over 6. Does that make sense to everybody? And one complete revolution would be 12 pi over 6. So, kind of using those two values together, could you tell me how big T would be? That's terrible. If we're able to trace and get there, what would T be there? T would be 11 pi over 6. But the ordered pair, radical 3 or 2, comma, negative 1/2. Take your calculator real quick. Type in sine of 11 pi over 6. Make sure your mode is got to be in radians. Negative 1/2, right? Okay. Type in cosine 11 pi over 6. 0.806 or something like that. Okay, which is radical 3 over 2. All right. So we're seeing some values that we can develop and access as exact values without the use of our calculator. We understand this concept, right? Now there's some other points on here that are important for us to understand, and I kind of want to show you these other points using maybe a different approach. I used the special right triangle here, right? Well, could I do the same thing maybe if I had maybe that triangle there? Can I use a 45, 45, 90 triangle concept to find out that this point here is radical 2 over 2, kind of radical 2 over 2? Okay, and we'll talk about that here in a moment. But we could use the special the right triangle. That's kind of what Chapter 5 was getting at, is using right triangles to find that ordered pair, essentially. But I want to use a different approach because I just think it's good to see multiple ways of getting the same thing. If I were to draw let's actually come down to we'll come down here. We're going to draw in that line right there, and that line is going to divide the first and third quadrants in half. Does anybody know the equation of that line that does that? Y equals x. Okay. What was the equation of the circle? X squared plus y squared equals 1. Are those two I'm going to call them both curves. Do those two curves intersect? Yeah. Right? They cross one another right here, don't they? And right there. Okay. And we should also know, if we're cutting the first quadrant in half, okay, that angle right there would be how many degrees? 45, right? Or pi over 4, right? Okay. So because of that relationship, that's 45 or pi over 4, we should be able to maybe find this ordered pair using a different approach than special right triangles. But special right triangles do work as well. If these two curves intersect, then that means that at that point, the x value and the y value for the red line are exactly the same as the x value and the y value for the black line, right? Or black curve. So can't we do this? X squared plus y squared equals 1. We also have y equals x. We've got a system of equations. Can I take this bottom equation, and wherever I see y, replace it with x? So that gives me x squared plus x squared is equal to 1, right? How many x squared does that give you? 2x squareds. So 2x squared is equal to 1. X squared would equal 1/2, right? And now x would be plus or minus that, which will reduce, or rationalize, I guess, not reduce, to plus or minus radical 2 over 2. Is that right? So what we're saying, we got two answers here, right? If this x value is in the first quadrant, which answer are we using for that ordered pair right there? We're using the positive one or the negative one? Yeah, that one's referencing the positive one, so that's radical 2 over 2. Now, we have the requirement that anything on that red line, the y value is exactly the same thing as x value, right? Is that black point on the red line? So isn't the x value and y value both have to be radical 2 over 2? Does that kind of make sense? Where did the negative radical 2 over 2 go? Goes to this point right here. Okay, I kind of solved it simultaneously for both points of intersection. And we get x to be negative radical 2 over 2. And anything on that red line has to satisfy this condition. Your y value has to be the same as your x value. And we get that. Okay. So now when they ask you, you got your t, let's say that the question is find the point that goes with t equals pi over 4. Well, that blue curve then, that blue arc, would be your pi over 4. And the point that goes with it, radical 2 over 2, counter radical 2 over 2. Okay? If that's pi over 4, then that has to be pi over 4 too, doesn't it? Does that make sense to everybody? Kind of using, maybe using that and that line together to help us realize that that pi over 4 is the same as that pi over 4. So what if I asked you, what is that t value? The red t value would be what? That's pi, right? If I would have stopped right there, that would have been pi, which is the same as 4 pi over 4. And then Jared's saying another pi over 4, right? Okay, so 4 pi over 4 plus pi over 4 is 5 pi over 4. So if I say t is 5 pi over 4, what's the order pair that goes with t being 5 pi over 4? It's that one there. Okay. Is that kind of something we can do, guys? All right, now, there are some other ones. What if because we got symmetry, right? This one here was pi over 4 is radical 2 over 2, comma, radical 2 over 2. If I fold on the y-axis, doesn't that point go right here? What's its ordered pair going to be? Yeah. And the guys, that can actually be found, I'm using symmetry to find it, but it could actually be found with the system equation with the circle in that line. Anybody know what that line's called? Y equals negative x. Okay? So all that means, and we're going to plug back in, you would still find x to be equal to plus or minus radical 2 over 2. But now your y has to be the opposite of that, right? So here, x is negative radical 2 over 2, so your y is opposite that. Okay? Now that would be, so this would be pi over 2, or 2 pi over 4. So this arc here, that t, would be 3 pi over 4. Can I, obviously I reflect over the x-axis, we get that one, which was 5 pi over 4. But can I reflect then again over the y-axis and get that one, which would end up being 7 pi over 4, which its coordinates are going to be radical 2 over 2, negative radical 2 over 2. And what's nice here is that you see you essentially have 4 points there, right? 4 points, and they all have the exact same distances that the point in quadrant 1 has, right? It's just depending on, is it residing in the second quadrant, third quadrant, or fourth quadrant, where I adjust the plus or minuses out front. Okay? And that's what they refer to as eventually the concept of reference angles, or reference points, I guess, here in this section. They're going to ask you, okay, if you have, 5 pi over 4, well, that's a pi over 4 reference angle. So what is the order pair that goes with pi over 4? Right, with 2 over 2, comma, right, 2 over 2. And then so what's the terminal point that goes with 5 pi over 4? It's the same exact numbers, except for 5 pi over 4 is in the third quadrant, so they're both negative. Okay? And we'll get a lot of practice at that. That's kind of the gist of the whole process and where a lot of these numbers are coming from. Okay. Now I did show you using special right triangles, with this being like a 30-degree angle. There is a line, okay, I don't know it off the top of my head, that will intersect the origin here at 30 degrees. And we could use the equation of that line with x squared plus y squared equals 1 with system equations to get this radical 3 halves, comma 1 half ordered pair back. Does that make sense? Okay. But off the top of my head, I don't know what that line equation is. Okay. But it is feasible. Now, if they go negative t values, so negative just means that you're going clockwise now. So I'm going this direction. Okay, so that would be 3 pi over 6, right? Five pi over 6 is going to be about right there. Okay? And that ordered pair is going to be negative root 3 over 2, negative 1 half. Now, I think it's kind of hard to maybe initially the first time you see that. Why is it that? Why is it negative radical 3 over 2, comma negative 1 half? Well, let me put in another circle here and draw the comparison for you that we know, because of what we did earlier, that we have this terminal point that was t equals pi over 6, we knew that that was radical 3 over 2, comma 1/2, right? We use special right triangles to determine that, okay? How do I get this negative 5 pi over 6 here, this negative 5 pi over 6, how do I get that to reference back to here? Well, a reference point is exactly the same thing. It's kind of what we talked about in Chapter 5 with reference angles, okay? How far would this point have to move? How long would that arc be right there that I have to move that point to get to the x-axis? So if I go this direction, that would be pi, right? Or 6 pi or 6 all the way around to there. So if I go to 5 pi or 6, how much would that red have to be? Yeah. That red would be pi or 6. And we're going to call that red one, if you remember, we in Chapter 5, we were dealing with the central angle as theta and theta bar, right? Okay, theta bar being the reference angle. Now we've got t, which is our arc, and t bar, which is our reference arc, okay, or reference distance, okay? And now that's going to help us determine the order pair. So what is pi over 6? Our reference of pi over 6. Pi over 6 is that ordered pair. So I know 5 pi over 6 is going to have the exact same ordered pair. Okay? But negative 5 pi over 6 shows up in what quadrant? The third quadrant. And that's what allows me to then adjust the plus or minuses of those two things. Is that okay? All right. So some examples here when they're asking you to find the reference number. If I just did 5 pi over 6, okay, so 5 pi over 6, the arc would be like right there. Okay, how much further do I need to go to get to? We always want to try to get to the x-axis. So how much further does that have to go to get to the x-axis? Pi over 6. Okay, let's go 7 pi over 4. What is it's the same thing that we did with angles, guys. We know all the way around was 2 pi, right? But if I'm going to put if everything's in terms of force, I'm going to make this 2 pi 8 pi force. Does that make sense? So it just makes I think the addition or subtraction a little bit easier. So 7 pi over force is almost to 8 pi over force, right? How much further do you have to go to get your point back up to the x-axis? Pi over 4. All right, so what we're going to do tomorrow is look, okay, so I can find that reference point, okay, as pi over 6. That is going to tell me the ordered pair for 5 pi over 6. Then I just got to address the plus or minus. I don't know if at the beginning of class, I think I told you guys when I was in school, this thing was given to me. I was told to memorize it. And it took a long, long time to really understand and gain a grasp for what's going on. So you might be a person who says, we're going too slow for me. This is redundant. The pace will pick up, but I want to make sure that we don't leave anybody behind. And anybody's having to struggle and figure this thing out on their own, where these values come from. Because what's nice, if you understand where they come from and you forget one, and your memory fails you, hopefully I've helped you establish a technique for developing them. Does that make sense? Okay. Because they are going to be, eventually I'm going to ask what's the sign of 7 pi over 4, and I want radical 2 over 2 real fast. Okay. If I ask you what is the cosine of 5 pi over 6, and I want that negative radical 3 over 2 real fast. Okay. And we don't want to grab a calculator and all that kind of stuff. I'm going to extend the cosine homework till Monday. So 5, 6, I think we do till Monday. Have a good day. Thank you, too.